This last part of this series, I wanted to just do sort of a full overview of everything, just so you can kind of see it all in one place, as we obviously built all these pieces separately. Followed by, I want to just do a quick experiment of, okay, how could we, use the core stuff we've built to actually create another game? We likely won't finish that entire game. It's just kind of to show like the workflow of working in this way. So just as a review, we will start kind of right at the start of the application. And I'm going to just clean up some stuff as we go, because certain things, such as this, is no longer imported, because we're importing Crazy 8's provider instead. So our main.dart is very simple. It has its main function, which ultimately calls run app, as every Dart Flutter app does. But rather than just going right to our app, we are actually wrapping it in a multi-provider that allows us to have multiple providers. I did multi-provider because we, in theory, might have different games, and it's just a way to have multiple ones. Also in here, we have our public navigator key and root scaffold messenger key. This is ways that we can get access to the context, as well as the scaffold globally in our app, which is necessary when we're trying to do something outside of the widget tree. Simple app, and all it does sets some variables here and loads the game screen. Game screen is also quite simple. It's a stateful widget. And it basically, all it does is sort of have an app bar that has the new game, new game button, which essentially when pressed just creates these two players. Now this is something you could easily update and create some kind of dialogues to collect the players' names and whatnot, but we've just kind of hard-coded these for simplicity. So nothing really crazy going on here. And in fact, this could probably be reconverted back to a stateless widget, but I'm not going to worry about that. The body of it is the game board. And the game board itself, UI-wise, is our most complicated screen. Essentially, all it does, and all it does is quite a few things, is it is a stateless widget, which is cool. Even though there is state in here, we're relying on consumer. So in the main build for this, it is actually wrapped into consumer of our Crazy 8's game provider, which this model is the most important part of this. This is essentially a representation of the instance of our provider. So because we are doing because we're wrapping this consumer, this will rebuild every time that our model tells it to rebuild, meaning calling something like change or notify listeners. So within here, we do have, and I'll show you in the UI, let's just make a new game. We do have a column, and that's so that we can kind of have this bar at the very top. Then there is a stack, which contains all these things within here. Essentially, there's an align that controls this. There's an align that's centered for this whole area and a line that's bottom centered for this. This itself is also a column because we wanted to put this button in here. So that's kind of the layout of it. Now, within the most important one, arguably the most important one, the middle one, it has a gesture detector around this deck here, which essentially calls our draw cards function. And it is the deck pile. Then we have just a little bit of a spacer, and that's where we have the deck pile here for the ones that we can see, the discards. So two different deck piles there. Or sorry, that's why deck pile and discard pile. Deck pile is okay, we can't see, they're turned upside down, and discard pile is actually a stack of multiple cards, which we're passing in based on our model. We also have this little thing that, if our model has declared a bottom widget, we will, if it's not null, we will display it here. And that's actually, in this game, this sort of trump indicator here. We also have a top center for this and a bottom center for this, which this one's a little more complex because it is not an AI player, so we need some kind of functionality such as ending the turn. All right, and that is also part of that column here is this this card list, which takes a player attribute and goes through. So let's take a look at, for instance, card list. So card list itself has a few parameters, the size, and that's just something so that we could update the size as a ratio. Right now, the default's always 1, but we could override it to make the cards bigger or smaller and so on and so forth. Also a player, which is this sort of model that we've created. They have a name, they have a Boolean whether there is human, and they have a list. You'll notice this isn't final because we want to be able to change it, but there is cards that we instantiate, just an empty array, and a couple helpers to add cards, remove cards, and just a getter to check if it's a bot, which is really just a reverse of is human. And then we have a function on play card, and you can kind of see that when we pass this in, we have this function. It is expecting a card model to come back, and we then go to our model, which is our game provider, and we run the function play card by picking, oh, we want to use it's this player, and this is the particular card. That function itself actually just gets passed through, which is pretty common in Flutter. You make a function that doesn't even do anything here, but just gets passed through to the next thing. So this is a list view builder of in the direction of horizontal, which allows it to scroll this way if we had enough enough cards, and I imagine I can emulate that just like that. And it loops through and all the cards that that player has, and essentially returns a playing card. And the playing card itself has a card model. Now the card model is, there's an image, there's a suit, which is actually just an enum of suits, hearts, clubs, diamonds, spades, and a value, which could be like, it's actually a string of 1, 2, 3, 4, 5, all the way up to 10, and then spelt out Jack, Queen, King. Also in here is just some helpers to convert things between that string name to our enum and the other direction. We also have some stuff to make the Unicodes or the emoji symbols for each of these things, as well as something for suit to color, which if it's hearts or diamonds, it's red, otherwise black. Okay, our playing card essentially has an on tap event on it. If the function passed in is null, it doesn't do anything. Otherwise, it does do it, and it passes back the card. And that's just so we can kind of conform to this idea that ultimately 2 layers higher up, we want to be able to call a function. It gets passed, that function gets passed in through here, passed in through here. If you tap it, it gets passed back, and it gets passed back, and this is where it actually ends up doing anything meaningful. And within here, it's pretty simple. It's just a container we have a constant for our card width and card height, so that we can, work with that and keep the ratio the same. And it multiplies that by that optional parameter of size, so that we could have bigger cards and smaller cards, by passing in 0.5, for example. A little bit of border radius just to give it that nice, curvy edge. And essentially we have something whether or not the card's visible, which will declare it to show a network image of that card's image, which is just the URL. And of course, if it is not visible, we just use this component we made called card back, which this is something you could improve very easily just by putting maybe a gradient or finding an image of the back of a card. This is kind of ugly, but it works. Okay, so that's that. That's our card list. Now, that kind of covers, I think, a good chunk of the UI. There's obviously some other components in here. We have sort of a modal to choose a suit, and you can go back and watch, how that all works. That's when Trump is declared. But UI-wise, that I think covers most of it. We've talked about some of the models. The card model, for instance. There's also a deck model, and that represents the entire deck. All 52 cards. And we instantiate it to get that going. There's also the idea of a draw, which is when you actually pick up one or many cards, and it essentially references a deck, but it just tracks kind of like what cards are in there and how many are remaining. Or sorry, how many cards did you draw? And this will be a list of actual cards of that card model, and then remaining in the deck. We also have a player, which we looked at, and the idea of a turn. A turn tracking just tracks all the players involved. What turn number are we on? Who's the current player? And also we have sort of a getter for the other player, which just kind of looks for the first one that isn't. Again, this will work no problem for a 2-player game. This would have to change, the logic would have to change a lot if you were looking at having more than 2. But not a terrible challenge. We looked at the screens. There's really only one, and that's pretty fine. The other 2 pieces where I think we probably spent the most actual time in were our providers and our services. So we did build a service called Deck Service, and this works with this API that we went into right at the very start, which is the Deck of Cards API. It's a nice API for, I think, really just for learning purposes was its purpose. Because again, we could have fairly easily built this whole thing with memorizing all the cards, keeping them in memory, as opposed to working with an API. But the purpose of this whole Flutter tutorial was really to kind of like show all the pieces of a general app that you would build, which generally has an API, and that's why I chose to use it. Ultimately, this is a pretty simple file because we did a lot of the heavy lifting in this API service. And this is kind of just a way to work with HTTP while, kind of not dealing with the intricacies of it. Because as you can see, the code here is pretty clean. It's just, okay, await HTTP GET, pass in the path, not even the whole URL, but just the path, and then some parameters in a format that programmers like to work, which is basically like a map, right? As opposed to when you actually do a GET request, you are writing things like, param1 equals blah, blah, blah. Then you have to do like an ampersand to get the next thing, and so on and so forth. And that's really tedious and ugly. So our API service sort of had a helper to get the URL, and that's you can pass in parameters and it loops through and builds that query string I was just showing. It also does some stuff to make sure there's no double, some extra slashes and whatnot, and then it parses the URL. And then our HTTP GET function, which is what we're interfacing with right here, it expects a path, and it builds that URL based on the path and the parameters that we've passed in, if anything. Then it does the response, and it JSON decodes it, and we actually run it through a UTF-8.decode just in case the API we're working with isn't super friendly. This will just clean up strange characters and that kind of stuff. So yeah, that's kind of the service, and all it really did, we have something to get a new deck and something to draw cards. And it's a pretty cool service because basically our sort of like business logic of what's in the deck is handled server side. And there is an advantage to that because if you did make this a multiplayer game, it makes it a lot harder to cheat when there's sort of this general center of truth that you can't really hack unless you really know what you're doing. So that's our sort of like services, and then we have providers. So we built something called the game provider, and this is our root provider for any game that we might build, such as Crazy Eights. And this on its own, we actually, we worked with this for a while, and we made a very simple game of just, okay, you can draw a card and you can play a card. But it has things in it that, remember, stuff about the deck, what players are here, what's in the discard pile. So it's this sort of like generic game state object that any of your games could make use of just to remember, okay, what maybe happened last turn or what's trump or that kind of thing. We have some functionality to create a new game, which goes and gets that new deck with our service and just kind of resets everything and runs this setup board function, which in this case does nothing, but we can override this in our specific game. Yeah, and then some other helpers like drawing cards right to the discard pile as opposed to a player's hand. Some stuff that just set what was last played, which is helpful in many games. It's important to know what was last played. Some helpers of like, okay, can I draw a card? We don't need this print here. Something to actually draw cards. And this one's we'll go over this one a little more in detail. So essentially draw cards, we pass it a player, which is required because it's not inside these brackets right here, these braces, because we need to know where to draw it to. And then we have a count of 1 as the default, but you could in theory pass it, I want to draw 8 cards, 10 cards, 52 cards, whatever. We also have this thing, allow anytime, because we do have this logic to make sure that someone can't really cheat. Like you're only really allowed to draw the card if can draw a card is true, except in the case where you override this and say this is true. That is good for like, in the board setup or something like, I just played the Queen of Spades, you have to pick up 5. Our program needs to not follow the general rule that you set with can draw a card because we're overriding and enforcing it. Yes, this person has to draw these. Then we do the draw, which is an asynchronous function because it is working with this API with the service that we made to draw cards, and we pass in what the current deck is and the count because we might override that from 1 to something else. Then we take whatever that draw is. Draw has something called cards, which is a list, and we actually add those cards. And this was just that helper function we made where we just take cards and we combine them together, spread and get the new ones, and then we have a new list. We also increment the draw count. So draw count plus equals 1 if the default is true, and that's just part of our logic that can be used. For instance, if the game requires you to draw a card every turn, we want to we would imply that rule. And then we also take the current deck and we just set its remaining amount to whatever the remaining of this draw is, which is just something we get back from that API. And then, of course, we have to remember anytime we want the UI to reflect something new, we want to notify listeners. And that's so that our consumer that's wrapped up in our game board right here, it knows that this function should rebuild. Some other helpers here. Play card is somewhat similar to draw cards, except you're playing the card, which does a bunch of stuff here, like incrementing the action count instead of the draw count. We also do this thing called apply card side effects, which is empty in our base game provider because this game is so simple. There is no side effects. But in Crazy Eights, for instance, we override it to do things like, oh, if it's an 8, let them change trump. If it's a 2, someone pick up 2. Some helpers to check if you're allowed to end the turn, something to actually end the turn. And after we end the turn, if the current player, because this is going to increment the player, the current player is a bot, we run this function called bot turn. And bot turn in our base is really just something where, okay, he waits for half a second, or she draws cards, default of 1, so draws 1 card, waits a bit again, and then assuming the cards aren't empty, we wait for another second because the bot's thinking, and we play that card. So this game is very boring. Essentially just picks up a card, plays that card, picks up a card, plays that card, and so on and so forth. Then we also want to, assuming the logic is like I can end turn, which would be true in this, then it ends turn, which essentially calls this again. But of course, unless you have 2 bots in a row, this wouldn't get called the next time. So it's kind of like the flow with a bit of the very basic AI. We have stuff just to finish the game, which really just shows a toast in this game, game over, because there's not really even a winner in our base game. You can't, and in fact, I don't even think this can get called because we don't have any logic. I don't think we even have any. Yeah, if game is over, well, let's see. Right, so if you played long enough and all 52 cards, basically if you have 0 cards remaining, it will call that game over. So this game can end. And then we do have a helper for showing a toast, which works with that. Because we're outside of our build tree, we can't have access to context in the same way. So we're using that root scaffold messenger keys current state to show snack bar. And we show this snack bar, which takes a required message and amount of time. And we could even pass in a snack bar action, maybe an undo button or something. So that's our game provider. And this is kind of like our core engine. If anything, it's a game engine for a card game, and it's not. This could get a lot more. You could add a lot more functionality here because we're not. We made Crazy Eights is a pretty basic game. If you're trying to make something like Euchre, you would probably end up not just making your own provider for it to inherit this, but also probably adding more functionality here because there's a lot more going on with a game like that. Okay, lastly, our Crazy Eights game provider, which essentially inherits game provider. So this has access to everything public that game provider has. So you'll notice some things are underscored. We can't, from Crazy Eights game provider, actually access this right here, but we can access the getter, which we've made. And this is just a common way of doing things to kind of protect certain variables that you don't want other things to access, but still giving them a way to access a reference to it. So what we did in here is every time you see override is we're actually overriding something that game provider has. So for instance, setup board, which was an empty function in Crazy Eights, we loop through all the players and we draw. This should actually be 8. I think we made a change near the end just to make debugging a little bit faster. And this is a case where we want to do that allow any time because there's not really a current player right now. It would return false, being like, this one's not allowed, you're not allowed to draw a card now. It's not your turn, but we're overriding it to say, yeah, nope, just let it happen. And then we actually draw a card to the discard pile because that's just something that happens in Crazy Eights. One gets flipped up from the top. And then we want to set last played, which is just kind of like setting in memory that the seven of spades, for instance, was played, which actually does these things like uses game state object to keep track of the suit and track of the value. Okay, then and then we just reset the draw count and action count to 0 because although action count probably doesn't matter, draw count technically at this point would be 6, or now that we've changed this would actually be 16, and that would kind of mess up things. So we just reset it back to 0. We also override the getter for can end turn, and in this case, if your draw count is greater than 0 or your action count is greater than 0, you can end your turn. The bot can end their turn, or you can, player can end their turn. And that's because in Crazy Eights, you either have to play a card or you have to pick up a card, or you can do both. You can pick up and then play, or stupidly, you could technically play and then pick up. But the whole point of the game is to get rid of cards, so there's no real reason to do that. Then we have something for overriding can play card because it's a little bit different. I think in the base one, it's actually just yes, you can play that card, return true. But we kind of check some things like, okay, first of all, if for some reason there's no last suit and no last value, which I mean, in our logic, that's not really possible, but we're just kind of protecting ourselves. We say, yeah, you can't play because you just can't. We check, okay, if the card suit is equal to the last suit played, you can play. Also, if the value is the same, and those are just rules of Crazy Eights. You have to follow either suit or follow the numeric value. Or we have this thing that, hey, like if the card value is actually 8, you can play it because you can play an 8 anytime. It's a wild card. Our side effects, this was a pretty fun thing. Remember the side effects in the base is nothing actually happens. But here we check some things like, okay, if it's 8, and if the player's human, we're gonna show that sort of chooser modal, which is just like a pop-up that comes to choose one of the 4 suits. Otherwise, we actually have a little bit of AI logic here when it is the bot. We just look at whatever their first card is in their hand and set it to that suit. This logic could be a lot smarter, as we talked about. We also set, because when this happens, when you play an 8, you pick a new suit. We have to remember to set the game state to that suit, and we have this helper to set trump, which basically is just the little thing that indicates that hearts is trump right now. And then we show a toast, and that's a helper that we already looked at, where we just pass it a message. So the current player name has changed it to whatever that suit name is. We also have some, things for 2, which makes the other player, draw 2 cards, and we have to do, allow any time because technically they're not, allowed to draw a card because it's not their turn, but we need them to do that. We have something similar to 2, where if it's a queen and it's spades, they draw 5. That's the queen of spades. And then we have something where if it's a jack, that player misses a turn, and we had a helper function called skip turn, which essentially just increments the turn twice. Okay, that looks good. That looks good. And again, like we want to notify listeners when things happen so that UI can update accordingly. We also overrode the game is over. If the current player at any time has no cards in their hand, the game is over. And we have this finished game that we override to actually take, instead of just saying game over, we do kind of have a winner. We know that if it's because current player is what we're checking, we know that whoever the current player is the winner, and we can show that toast. Now, there's more we could do here where, we say want to play again or whatever, but I don't think we need to worry about that. Okay, then bot turn, we also made a little bit smarter. Again, this function you could make this 1,000 lines of code and make it really intelligent. But basically what's happening here is we do a delay, and this is just to give the idea that, hey, the bot's thinking about stuff. It just makes it a little more fun and not happening instantly. Then we loop through all the cards in the bot's hand, and if the bot can play the card, we go and we play the card and we end turn. And we return out of this because we don't want it to keep, this returns out of the whole function. We don't want it to keep looping. Now, if it gets through all of this and this hasn't returned, we do another delay. He's like, I'm thinking. Then we're like, okay, you got to draw a card. And then, okay, I'm thinking. And then it checks to see if that last card, because when we draw a card, it gets appended to the end. We can just be like, hey, if I can play this one, then play it. Because you're allowed in Crazy Eights to draw a card. And if it becomes something you can play, you play it. And then we end turn. Obviously, this could be smarter where, hey, let's find, first of all, before just like returning out of here, let's make, like a list of all playable cards. Um, cool. We know with three, let's say like the bot has three cards they could play. Then you write some logic to kind of be like, oh, okay, what suits are these? Hey, I have more clubs than diamonds. I should play a club because in Crazy Eights there's a good chance that on my next turn it'll probably be a club again, rather than changing the suit prematurely and then being like, oh, now I can't play. Just basic, basic logic there. And yeah, that's kind of, in short, really what this project does and how it works. And I hope, kind of as much as I tried to review things as we go, I hope this sort of final review kind of like makes everything click if it hasn't yet. Again, this is basic. This is nothing. This could, like I mentioned, this could be a lot better. There's also some, some slight missing things, I'm sure. And I'm sure even, if you download this off GitHub and you play with it, you might still find some bugs because I'm sure it's not perfect. We kind of, built this live. But I think it's a cool, a cool way to think about things. And yeah, I think it's interesting that we are something that could completely be client side. We are integrated with an API again, just for learning purposes, and to kind of like deal with asynchronousness, because when you have an API, it's nothing happens instantaneously, and that's why we have all these awaits. So I'm going to just to kind of give people a starting place of, hey, I want to make this game. I'm going to, and this is a pretty blind coding experience that we're about to get into right now. I did have a lot of this tutorial, lesson, course, whatever you want to call it, pretty planned to an extent. But this is now me being like, hey, I just watched this tutorial and I want to make my own game. So let's just play around with that. And I apologize if mistakes are made, and they will be. So what I'm going to do first is make a new provider. And the game that I have in mind is called 31. It's a pretty fun game. 31 game provider dart. The idea with the game, before we write any code, is players always have three cards in their hand at any time. So they're dealt three and they have three. And they can choose to pick up from blindly from the deck, or from whatever card is on top of the deck. And they always have to discard at the end of their turn. So the logic's a little bit different in Crazy Eights, in the sense that in Crazy Eights you can have 8 cards, 9, whatever. In this game, when you finish your turn, you always have 3 cards. And the intention of the game is to have 3 cards all in the same suit, that are as high as they can be. Meaning like a 5 is worth 5 points, a 6 is worth 6 points, a 10 is worth 10 points. Now a Jack, Queen, and King are also worth 10. They're considered just face cards, 10, and then aces are actually worth 11. So the idea is, in an ideal world, you actually get 31 points, which is you having an ace and 2 face cards or a 10 in the same suit. But the cool thing about the game is you can essentially, if you think you are winning, if you think you have a good hand, meaning maybe you just have like 28, but it's pretty early on, you can essentially forgo your turn, and that's called knocking, and you are essentially, then the other player gets one more turn to try and do it, and then the hands are revealed, and everyone, whoever has the most points, wins. So I'm going to try and make this happen for us here. There will be some changes we will have to make to game provider, some additions, because for instance, we don't currently have a way to draw a card from the discard pile, only from the main pile, but that should be fine. So let's get to this. I don't know how long this is going to take. This might turn into a two-parter video because I know we're already 30 minutes in. But let's just see what happens. So we're going to make a class called 31 game provider, and it's going to extend the game provider, and we're just going to do that. And that's our starting point. And we are going to go into our main.dart, and we're just going to add another change notifier here, or change notifier provider, and to create, and it's going to do the 31 game provider. That way it's, and this is why I want to use multi-provider, so we could support multiple games. Then in our game screen, I believe, we have a Crazy Eights game provider. And now in an ideal world, if you were building a game where it's like, oh, I want the user to like, we have 10 different games, you can choose it. The logic here would have to change. You wouldn't want to just hard code whatever, but it'd be pretty simple to do to, kind of have a menu screen, and then the actual provider itself gets passed to the game screen of which game you're wanting to play. But we're not going to worry about that at this time, or probably ever. So we're just going to go 31 game provider, 31 game provider. And then I think in one more place we need to do this is in our components, our game board. So this, we just need to say it's not actually a Crazy Eights game provider, it is the 31 game provider. So now I'm just going to do a bit of a refresh here. Now what's interesting is this is just going to start working in the sense that because we're inheriting this, we're getting that sort of base game that we made, which the base game, again, is I draw a card, I can end my turn, he draws a card, he can decide to play, and our AI says, yes, you should play, and so on and so forth. I'm going to draw a card. So now because we're just inheriting this and not overriding anything, we're back to the core game provider, which is a kind of nice, clean slate. So I think the first thing that's worth overriding is sort of that setup board. And in VS Code, I can kind of just start typing, and it knows, because I'm extending this, that there's something, and it'll actually kind of throw all the boilerplate in. Now this is an async function, so we do need to add that. It wasn't smart enough to do that for us. Now, if we just kept this like this, essentially, like, we're overriding it, but we're using the super. And what this means is, like, it's going to use, this version of setup board. Obviously, that's not what we want to do. And in fact, VS Code gives us this warning being like, don't override to do a super method invocation with the same parameters. This should be helped say in setup board. All we want to do is like do a, show a toast of like, welcome to my game, and then still function as it normally would. That's a good use case for this. And we would see if we did, refresh this game, or we should see when the setup board happens, welcome to my game. So that's kind of cool. But obviously here we want to do this a little bit differently. I'm going to open up the Crazy Eights one, because it is going to be kind of similar. And I'm just going to copy and paste, as we like to do in programming. So instead of drawing 4 cards or 8 cards, we are going to draw 3. We are going to do that allow every time. We do draw 1 to the discard pile. So there are, I picked this game for a reason. There are some similarities, where something like euchre or poker, we'd be looking at a lot of differences, but nothing you couldn't do, I don't think. We don't actually, in this game, there's no concept of, like, we don't really care about what someone played last, as far as I can think. So we won't worry about putting that in, but we do want to make sure we set the draw count back to 0, just so that stuff works properly. So there's our setup board. And if we were to make a new game now, we should see we all have 3 cards, and that 1 card goes here. So that's the first override. The next thing we would want to do is, what else do we override here? Can end turn. Sure, let's just do that. So in this game, can end turn, it's a getter. And I don't know where that semicolon came from, but sure. We want to, so you always have to draw and you always have to play. So if turn.draw count is equal to 1 and turn.action count is equal to 1, return true. Otherwise, you're going to return false. Now, similarly, and I'll put this in the same spot, can draw card. Oh, that's where it came from. Right. Okay, can draw card. So I can do it. I'll do this the common way first, and then we'll do a faster way of doing it just for fun. Draw count is less than 1, return true. Otherwise, return false. Now, this could be cleaned up in a much simpler way, where we can actually say return turn.draw count is less than 1. So this is going to return either true or false. If the draw count is less than 1, it'll be true. If not, it'll be false. So that just cleans that up. And in fact, we can also do something similar here. We can literally just do this. And this is just, nice and clean and less lines of code to maintain. basically it's going to return true if these two conditions are true. Otherwise, it will return false. We can also do can play card. I don't know why I'm not getting my, I thought it was, yeah, can. I don't know why sometimes VS Code is like, I don't want to help at all. So we'll just type it ourselves. Override can play card, which is a bool. Now this one's not a getter because we have to pass in a card model of card. And in terms of can play card in this game, you can, it doesn't really matter what the card is. We still have to conform, to this, but it doesn't actually matter what the card is. All we really care about is we're going to return if um, turn dot action count is less than 1, we can play a card. Now, also in this game, although like I don't know if there's a hard rule about this in the actual game, you're supposed to pick up before you discard, which is just makes sense because why would you discard and then like be like, oh, I picked up something else? So let's just make it easier on our players to enforce that obvious strategy. So we can also say if turn dot draw count is equal to 1 and turn dot action count is less than 1. So it's basically like, hey, you have to pick up first. The draw count has to be 1 in order to play, but the action count must be less than 1. So let's just see with this sort of logic and a quick, I just like to, I don't have to rebuild. I know that hot reload's great, but I like to kind of just do things clean sometimes. So in theory, I shouldn't be able to play a card right now based on this logic here. So I'm going to try to play a card. No, no, no. But I'm going to try and draw a card. So I get my 4th card in my hand. And then I am going to, now I should be able to play a card. And strategically right now, these face cards are pretty high. I should probably get rid of one of these. I can see the other player's hand, which obviously we need to disable that. But it's kind of fun to know what they have. So, and in this case, it doesn't really matter what I play because they have both of these. So I'm just going to play that. And then it should allow me to end turn. Now, this might be a little bit weird because we haven't written any bot logic yet. But it actually is kind of working as expected because our bot logic is just, hey, I'm going to pick up a card, I'm going to play a card. So they're kind of just randomly playing. They are going to lose, but maybe not. I've been beat before. Okay, so can play card is pretty simple. What else? Apply card side effects. There's actually not really any side effects in this game because it's really just like this is a game where you're just trying to collect, the highest cards. So I don't think we have to worry about that. Let's do game is over. Game, yay! This time it got me back. You got me, VS Code. Okay, so this is actually going to require a bit of extra work. So I'm just going to return false for now, and we'll come back to this because we kind of have to do something interesting for that. Finish game. We'll worry about doing that after. Let's keep our bot turn as is, and just so that we kind of have it stubbed out, I'm gonna put it in here, and I'm gonna just do what we talked about before. We're just gonna call the super one for now. So we have it here, it's ready to go, and I'm just gonna like print something like bot turn just so VS Code doesn't complain, and I'll even make like it's a to do. This is a fun thing to do. Speaking of to dos, in VS Code, it's nice to kind of do to do update bot logic. And the reason for it is you can go in your problems tab and you can actually see all of your to-dos, update bot logic. It's just a nice way to track things without searching for the word to do. And it even, at least in my color scheme, makes a to-do actually looks, different. See how it was like bright orange. So just a fun fact. Okay, so we got, this is actually coming together okay, but there's some new stuff we do need. For instance, we need, yeah, actually, let's start with that. So in 31, not only can you pick up from here, you could actually pick up from here, which is interesting. So we need logic to do that. We don't even have that in our main game provider at all. So let's get our main game provider open, and let's also get our game board open. So you'll see we'll have the discard pile. So discard pile doesn't have any functionality with it. It's kind of just a visual thing, but we are going to improve that. So we're going to have a final function, which will take a card, which will, oops, the function will have a card model return back from it, and we'll call it on pressed. And then we want to go this dot on pressed. Now this should actually be a optional function because we might not pass that through, so we'll keep it optional. And then now that we have an on press on the discard pile, let us wrap maybe the whole container in a gesture detector. I like gesture detectors because they don't affect anything about the layout. When you wrap things in like a button, something like that, like, you get padding and you get all this stuff. But gesture detector is just kind of like a raw, hey, this area is a hit spot. So we'll do on tap, and in here we'll go if on pressed does not equal null, then we can call on pressed, and we want to actually pass in a card. And for the purposes of now, we should just be able to take cards dot last, because last one will be whatever's at the top. Now, do use curly braces for all flow control. Okay, I will do that then. So now we have this function that'll do on pressed, and that way over here, we can then in our discard pile do a on pressed. And now we could have, I guess we could have actually just similar to here, we could have actually just wrapped our logic in here, but I kind of like the idea of having it on the object itself. So for now, let's just print. So this will take back a card, and see how it's kind of, Dart's really nice, or at least like VS Code interpreting Dart is really nice because it actually knows that this card is a card model, and that's only because we've passed in, the function will return a card model as the first parameter. So that's pretty cool. So let's just print that and save. And in theory now, if we go back to our terminal and click this, did I not save everything? Print card.suit. Let's make sure we're good. Oh, you know what? I probably do have to at least do some kind of state change, but let's see. So let's see if I pick this. No, I'm not getting anything. Let's find out why. So let's just start at discard pile. I like to kind of start at the very top or the bottom, I guess. And let's just print a test, and let's see if like the click is even working. So it's not even working on this. I wonder why. Gesture detector is wrapped around the container. Am I in the right thing? Discard pile, yeah. Yeah, why is this on tap not working? Okay, let's just, I'm going to just try something here, but I actually just don't understand. There's a gesture detector around the discard pile. Is there something that's like overlapping it? Let me just make it a bit bigger. That's very strange. Gesture detector wrapped around the container. Then there's a stack. Oh, maybe the stack is overflowing the thing. I'm going to just do one quick test here. Wrap with widget. There's a cool widget called ignore pointer, and you can set ignoring to true, which might actually just solve what our issue is. That was the issue. So our stack is, these things are on top of this container. So we could do that. We could have also decided, oh, let's put the gesture detector around the stack, and that's in fact what I'm going to do. So we'll wrap this with a widget gesture detector, and I'm just going to pass this whole guy here on tap, and let's just get rid of this one because we don't need him. Remove this widget. I think one of the things I love the most about like VS Code and Flutter is that kind of stuff, like, because it's so tedious okay, I need to erase this, but then I have to scroll down here to get rid of this. Like the refactoring tools are like make writing UI amazing. So now I should be able to click here, maybe. Wow. Is it because the playing card is, it's probably because the playing card is there. Now I could wrap it around the playing card, but then we're gonna get like so many gesture detectors stacked. So let's let us let us just do what we were gonna do anyways, and yeah, yeah, we'll just do it this way. So wrap with widget, and oh wait, why did it? Oh, okay, wrap. You know what? I like the way we had it. We're almost back. Okay, ignore pointer. We're just gonna do it this way because this was working. I can click this. I get test. I get suit of diamonds, so we know that's good. Okay, we're back. We're back. Okay, so on pressed, we want to call a function that we haven't made yet in our main game provider. So we have like play card, um, we have like draw cards. So we're gonna make a new one called, and the best way to put it, probably here, I think is good. We're gonna make it a. I don't think this will have to actually be a future. It's gonna be a return void, draw cards from discard. And we are going to optionally have a, what do we use? Not count, but I think amount, int amount, and it's going to be 1 by default. And we do need to pass in a player, which will be required. And I will do follow the same convention we've been doing. And let's just make, was amount what we've been calling it? Count. We want to do count. Let's keep it consistent. So draw cards from discard pile. So what would we want to do here? Well, we want to, first of all, get the first X cards, 1 card to whatever the count is, and remove them from the discard pile, and then give them to player. And I think we also want to increment the draw count because it's still like a draw. Now, if your game had more complicated rules where like you're allowed to pick up 1 from the discard pile and 2 from the normal pile, like you'd have to like be tracking something else. But for this game, this is exactly what we actually want. Okay, getting the first X cards. So we have access to discard pile. So first of all, let's first of all, even before this, make sure that this can be done. So we're going to make another helper. It will return a bool. Can draw cards from discard pile. And actually, it won't be a getter because we want to pass in this count. And we'll just do it like that. So we want to just check. We can just make this a simple one. If return discard dot length, if discards dot length is less than count, or sorry, greater or equal to count, we're returning. So if there's more or equal to, we are allowed to draw. So let's grab that. If, and we can say if not, can draw cards from the discard pile, count, return false, or just return. So we're not going to even let it happen. Very good. Okay, then in this case, we want to get the first X cards. So we can take our discard pile dot remove, I think remove range, and let's just make sure. No, that won't work because, is it like pop? Okay, I think I got my head around this. So what we're going to do is make a variable called cards, and it's going to be equal to the discards, and we're going to get range. And get range basically returns, these items from the start to the end. So the end will always be the discards.length -1 because arrays start there. And then the start will actually be discards.length -1 minus whatever our count is. So let's just see, first of all, what that would be. and make sure this is working. I will, let's actually, just to debug this a bit better, cards dot for each, and we can print element dot value. That should be enough for us to know that this is working as expected, hopefully. So let's save that. Make sure, oh, we forgot a semicolon. And we should get the hot reload. And if we go back here, if I click this, I get suit dot. Oh, but that was our function before. Oh, because we're not actually calling this yet. We want to go model dot draw cards and discard, and actually this value for us doesn't even matter. And draw cards and discard, and we got to take in the model.current current player, model.turn.current player. All right. So now if I click this, we get a error here. Yeah, okay, so we have like an index error, discards.length -1 minus count. Oh, you know what? I think get range, the first, maybe it's not actually start and end. I bet it's one's inclusive. Well, let's just see. I switched it so that, well, I won't explain it until I know what happens. Okay. Okay, we're going to look up this function a little bit more. Get range. So, this is part of programming, is knowing how it works. To provide the range, the start and end must be valid at the time of the call. A range from start to end is valid if 0 is the return interval behaves like a skip start. Get range. Okay, so we can look at this lovely example they put here. Colors dot get range 1 through 4. So 1. So it is the the whatever our index is. That part is a normal thing because it says it comes back with green, so it would be 0 would have got us red, and then 4 is returning, so 0, 1, 2, 3, 4. Get range 0, 1, 2, 1, 2, 3, 4. So I think, yeah. So it's like it's indexed and then not indexed by 0, something like that. So that means that this is correct, and let's see. Yeah, still not. Just a dumb little logic error. I had like minus the count, then -1 again. We don't want the -1. So we're just taking whatever the length is, minus count, and then discards.length, meaning it'll be going to the last one. So that makes sense. So we get our cards and we put that in memory. Then we should be able to just go discards.remove range, and we can use the same thing. And in fact, to do this, then let's just do final start equals this, final end equals whatever we had here. That way we don't have to type this out so many times. So this would just be start end and start end here. So this just puts these cards into memory, because when you remove, there's not a way to be like, give me those cards, my cards equal. This actually, remove range actually returns nothing. It's void. It just destructs those from that. So first we need to, before we remove them, we have to like know what they are. So we're keeping them in here. We can also get rid of this now. Then we need to give them to the player. So we can go player dot add cards, and we can pass in cards, right? The argument can't be assigned to the parameter list card model. What? Iterable. Oh, I think I have to also go get range and then go dot to list to make it a list. Otherwise, it's just an iterable. So now it's a list. Then we add the cards. Then we want to increment the draw count. So turn dot draw count plus equals, and we should just use whatever this count was, right? And I think we can, I'll keep those comments for now in case we need to fix this. So now, in theory, if I pick up this card, oh, and we have to remember to notify listeners. So this is going to do some funny things because now the state it did work, but it didn't. So let's just start over, new game. And I should be able to either pick up this or pick up this. I'm going to obviously pick up this because that's what we're doing. And we're good. Now I can't end turn, but if I play something, I can end turn. There we go. Now, can I still draw? I can't. Can I pick up this? Yes, I can. So we need to also make sure that can draw. Let's also go if can draw a card, or we'll just do if not can draw a card, return false. Because we want to, that same rule will apply in this case. So now I will restart. And we will, we have some cards, everything's good. Let's try picking up this card, and I can't end my turn, but if I play this, I can end my turn. Cool. Now, something else, trump doesn't really matter in this, so let's actually, in our game provider, have sort of like a, I'm just finding a good spot to put this. Where do we have trump? Set trump. Let's have just a getter called show trump, and it will return a bool. And it's going to return true by default. But in our specific game, we can override that too. And let's just do it here, because why not? Show trump, and we're just going to return false. So we're overriding that. This is the shorthand version of it, and it's perfectly fine. We could, do that in a few places, I'm sure. Then we need to actually make use of this. So in our a couple of places we could do it, I would say we have sort of like our yeah, let's do it right in the UI because it is a UI thing. So we'll go to our game board and bottom widget. And you know what? I'm going to actually change this, not show. Instead of calling this show trump, let's just call this show bottom widget and return true in this case. That way we can go if bottom widget is real and model dot show bottom widget. Now we have an error, and that's because in our 31 game provider, this is no longer a thing. There we go. Then we'll save everything, and because it's false here, we shouldn't see that anymore. But if we went back to Crazy Eights, we would, because it will just use the default. Okay, finally. Well, not finally, but so we have picking up and drawing, or picking up and discarding. Our bot doesn't do anything useful, but he is following the rules, which is good. Let's just see if stuff's working. I pick this up. I'm going to discard that and turn. Okay, I think we got most of it together. The last thing is, I think it's the last thing. We just need a way to essentially be like, oh, this person wants to propose ending the game, meaning, and then we have to like count who has the most points. So I will, because we're hitting the hour mark now, I'm going to continue that in the next video.